A little bit about the industry. Clearly, we all can look at a number of different forecasts from a number of different sources, but at DSM, we feel confident that this type of trajectory over the next decade will probably enjoy somewhere around 15 and 20% compounded annual growth. And if you look at some of the breakdown of that growth, you can see that specialty chemicals, but specifically polymers and fibers, will play an important part of that growth, and we'll talk more about that this morning. Open innovation. I mean, clearly one of the reasons that we put this panel together is none of us up here can do it alone. So in the spirit of open innovation, we really need to figure out how to work together, both backwards and forward. And today's panel obviously represents some key downstream partners and potential customers. So when you think of open innovation, I mean, it's not just the four companies that are up here. You know, DSM is very active in the venture capital space. We've made investments with companies like Verdesign, Segatis, Novomer, I think all of which are here at this conference. We also are very active in governments around the world, academics. I think many of us have research collaborations there. I mean, I would put DSM obviously in the category of a large company. We look to our employees for great ideas. They're not always that happy, as you see in this picture, but we do try to generate nice ideas. And we don't have anything formal, but I'd like to believe that Coim and AkzoNobel really serve as a potential customer to what we're doing. So what I'd like to do is just give you, not a commercial, but just a quick snapshot on how DSM is driving focused growth. A little bit about the area that I'm responsible for, which is bio-based chemicals and materials, a little bit about our approach and strategy, and then clearly what's the value proposition of renewable adipic acid to the industry and ultimately consumers, and what is our approach to partnerships as we look to this new value chain. So if you look at the top slide, I mean, these represent four pillars of DSM, who quite frankly has transformed themselves into a life science and material science company. So I'm not going to talk about all of them, but just real quickly, if you think about high growth economies, the BRIC countries, I mean, we kind of walked the talk this year. We put an innovation center in both India and China. In terms of innovation, we built the engine, now we're trying to double the output. So we have three emerging business areas, denoted by that pink bar at the bottom there. Not sure why we chose pink, but anyway, there's three there, and those are chartered to deliver €1 billion of revenue with reasonable margin, acceptable margin by the end of 2020. Sustainability speaks for itself. It's really a guiding principle for DSM. It's not only a responsible thing to do, but we think a business driver. And what I'm going to focus a little bit more on today, given the subject matter, is acquisitions and partnerships, okay? But suffice to say, I'm just trying to point the other ones out because you may be interested in our nutrition platform, our pharma platform. We do have a strong performance materials business. We're in engineering plastics and resins, but also are a large producer of caprolactam, falling under polymer intermediates, and as I said, I'm in the emerging business area. So I won't go through all these, but I just want to give you a flavor for some of the JV deals we've recently put together and some of the acquisitions. I think in this morning's panel, my colleague talked about a recent joint venture with Poet and cellulosic advanced biofuels. We announced that in January, very excited about that. Reverdia, you probably recognize from the previous session, that's the joint venture between Roquette and ourselves, DSM. And then over to the right, very proud to acquire a very successful company, Martech, and as well as Microbia. So I show this because I think it's important for companies to know that, you know, we don't always have to acquire something, or we don't always need to put a joint venture together, but we're very serious about not doing this on our own and collaborating with key companies. So let me zoom in, if I could, on my area. The whole emerging business area is run by a gentleman by the name of Anton Robic, and so he's responsible for both clusters. I have a counterpart who handles bioenergy. And one thing you may see on the slide, just to point out, is biodiesel. Many of you maybe don't know, we also have a collaboration there with British Petroleum, BP. But I'm responsible for that bottom area, bio-based chemicals and materials. And so I won't go into too much on succinic since there was a previous session. I obviously want to talk about adipic, but suffice to say there's other things in the portfolio that I can't disclose to you that are probably medium and long-term projects in this space that we're talking about today. If you asked me, if you said, hey James, you know, how would you guys differentiate yourselves? I would come back to tell you that we consider ourselves a value chain enabler. And so you say, well, what is that? And I would say a value chain enabler in our definition is we fully recognize that we can't do everything ourselves, but that being said, we are willing to not only develop the technology, but we're also willing to scale it up. So we're willing to bring our process and know-how to make sure that that first, maybe second commercial plant is successful with our partners. We're also willing to figure out how to backwards integrate. We're not interested in becoming a big agribusiness company, but we are interested to get to the best economics and to make sure that we're partnering with feedstock players to backwards integrate. So again, if you take a look, we try to really be active in those three parts along the value chain, and then even on some of these products, like DSM has an engineering plastics and resins business, we too can use the succinic and adipic acid internally. But not to forget about the power of the gentleman here on the table. The Akzo Nobels, the coins can really create a lot of pull-through, and not only that, a lot of the brand owners. So you have not only brand owners, but you also have NGOs. You may have heard recently, I think it was just announced last week, a very exciting production tax credit here in the United States. I believe the bill was approved, but it still needs to be enacted, but a definite, very positive step forward for the production of renewable chemicals here in the United States if that goes through. And then I won't point to any specific one, but arguably to say you've probably heard press releases and announcements about some of these first mover brands who are committed to bring more sustainable products to the marketplace. Now I love this slide mostly because I created it. Hopefully you will like it as well. On the left are dials, and I would say that they're more static. So what I mean by that, they're not polar. You have to have performance. Maybe there's different degrees of performance, but as we talk about the renewable chemicals and materials, you can't compromise yourself there. And cost also is going to be another thing. You have to be competitive. So maybe you're not cost advantaged starting out, but clearly the goal would be to be cost advantaged over time as you optimize your process. And for us within DSM, if we can't figure out how to have a lower carbon footprint measured by an LCA, then we will not introduce that new technology. But then if you look at the different dials, I would say they're more polar, so you could be at one of the extremes or somewhere in the middle. Do you go after a drop-in market like adipic acid, or do you go after something like succinic where you have significant market application development? Do you want to go after a single molecule, or do you want to build yourself a portfolio? What type of technology do you want to use? Do you want to use available feedstock like starch or sugar, or do you want to go ahead and invest in cellulosic, lignocellulosic technology, et cetera, et cetera? So when you take a look at that, I would say for our strategy for adipic acid, would follow something that you see here. And maybe just to point you to the very right, you see the dial on value chain partnerships. We don't have the luxury of going out to the public venture capital markets, although we could. So we heavily rely on value chain partnerships to help us take some of the risk and then share in the reward and the success of our technologies. So this to set the stage a little bit so we can kind of drill down into adipic acid and then pass it along to the next speaker. Biosuccinium, as you heard in the previous, we're very excited because we've been developing this now for 4 years, which is pretty quick in this space, and expect to have a 10 kiloton plant up by the end of the year. I'll show you a picture in a moment that you may have seen this morning, but in case you missed it. Renewable adipic acid, we're looking at taking our most promising route. We've worked on multiple ones and having that enter into development by mid-2012. That is very exciting, but just to be clear, that won't be on the market for about another 5 years. And 2 of those years really are the construction of a large plant, and I'll talk about that in more detail. And as I said, there's other things in the pipeline. Now this is in Cassano, Italy. So, it's a beautiful location, but this is a Roquette site. So we decided to build our succinic 10 kiloton plant there in Cassano, Italy. Now I pause here at this picture because if you've ever been to Holland, I'm actually from an Italian descent. I'm always the shortest guy when I'm there in Holland, but I like this joint venture with Roquette because with the French, I actually kind of blend in pretty good. Now I don't know whether you can recognize me. I'm the third from the left, but I'm not the guy with the big ears. That's a Frenchman there, so in case you introduced me. All right. Okay, so you might think as you see this video that this is being constructed in China, but that is not the case. This is the Italians doing this. And as I said, very exciting to see this is where we are, and we expect to have this plant up and running with commercial grade product to customers at the end of the year. So now you recognize this from the earlier slide in the beginning. This is the 6-carbon known as adipic acid. I won't go through all these applications, but suffice to say 60% of adipic acid goes in to nylon 6,6. So clearly that is a strategic application divided between engineering plastics and textiles. And then obviously a large portion, almost 25%, goes into polyester polyols, but then also plasticizers and esters and a little bit in food make up the balance. So if you say, hey, James, you guys are big caprolactam players, you got a strong nylon 6 business, why would you guys get into adipic acid? It's a logical question. Quite frankly, we looked at 100 different molecules. We saw an opportunity for a significantly more sustainable and competitive manufacturing process. Those were two of our key criteria. We really felt that we could make it cost advantaged. We found a couple multiple routes that we felt that could do that. As I mentioned earlier, we're a captive user, so adipic acid is not only a strategic molecule to AkzoNobel and Coin, it's also a strategic molecule to DSM. We use it in a product line called Stenil in our engineering plastics. And then, as we talked to industry players over the last 2 or 3 years, we found that, people are very receptive to putting a renewable, more sustainable solution in the marketplace. And so we felt that we would be able to have a successful partnership strategy early on. If you take a look at this slide, what I'm trying to illustrate here is that, we've looked at about 28 different routes. You can read the slide for yourself. We basically looked at process attractiveness and tried to assess the 28 routes on that dimension. And then we also looked at what we felt the technological probability of success was, and really decided to take 2 routes forward where we'll make the decision mid this year of which of those 2 routes to bring to the marketplace. But the value proposition, as I mentioned earlier, is that for sure it's going to be 100% renewable feedstock. It will have the high quality and purity that's necessary for polymerization, but also the other applications. Again, a little bit longer term, at least 2 years to build a large-scale plant, but about 5 years away. And we haven't made the final decision, but on the short list is probably sugar from sugarcane in Brazil and lignocellulose biomass, woody biomass. So those are the 2 that we're most closely looking at. And we've already, as I'll show you in a moment, feel very confident that it'll be a more sustainable process moving forward. People always talk about, well, what about the raw materials? And admittedly, we don't know what the price of oil will be. We don't really know what the price of adipic acid will be in the future, but we can try to gauge those. What I try to show here on the left, on the y-axis, is the sugarcane in reals per metric ton, and what's the oil price in dollars per barrel. And so if you were to plot all those points on the line, at any point on this line, if you looked at our fermentation process, one of the 2 routes we're looking at, above the line, the existing petro-based chemical would actually have an advantage on cost. Obviously not on sustainability, but on cost. And below the line, the advantage would go to renewable. If you then take a look at plotting all the data over time, over the last 10 years, you can see that in the majority of the cases, with some exceptions early on, the renewable still keeps an advantage despite some of the spikes we've seen in sugarcane today. Now clearly, if our process is not as cost effective as we think, you can see if I were to move that line down, we still have some room where we would still be above those data points. And then from an LCA standpoint, we don't know the exact number, but we have done an internal and an external assessment, and best we can judge because there's so many factors that we would at least count on about a 6-fold improvement in the life cycle assessment. And here you can see it's a comparison between what we think roughly is the best in class from a petrochemical process, 9 kilos of carbon dioxide emitted per kilogram of adipic versus 1.4 potentially for renewable. So a little bit now to finish off on our partnership strategy. We're working on the technology. We filed IP extensively over the last 3-4 years. We're really looking for a commercial partner to help go to the next step where we would build a demonstration plant and then ultimately a large-scale plant. And because adipic acid is a large market today, it's about 2.3 million tons worldwide, we feel that we could probably build 150 kilotons. If you said, hey, could you build a smaller one? Yeah, I think the answer is yes and still get to the best economics. But when you look at 2.3 million ton market, you want to get a return on your investment, 150 is probably the right size that we think is manageable. And so not only are we looking for commercial, we're actively talking to feedstock partners.